In this circuit, we use components like the LDR, transistors, resistor, and buzzer, along with the power indicator circuit we built earlier. Let's build this circuit in Tinkercad and simulate it. We will first build the power supply circuit as seen earlier. Let's draw the components mentioned in the circuit diagram. So we will draw the USB standard A connector, LED, red, and resistor of value 1 kilo ohms. We will connect as follows: the 5-volt positive of the USB to the terminal 2 of the resistor. This is the positive line, so we shall select the wire color red. Terminal 1 of the resistor to the anode of the LED. Cathode of the LED to the ground of the USB connector. This is negative line, so we shall select the wire color black. We will now complete the rest of the circuit, for which we shall draw the LDR transistor PNP resistor of value 10 kilo ohms and the buzzer from the component library and wire them as follows: emitter of the transistor PNP to the terminal 2 of the resistor 1 kilo ohms, collector of the transistor PNP to the positive of the buzzer, negative of the buzzer to the cathode of the red LED, terminal 2 of the resistor 10 kilo ohms to the emitter of the transistor PNP. Terminal 1 of the resistor 10 kilo ohms to the terminal 2 of the photoresistor LDR. Terminal 1 of the photoresistor LDR to the negative of the buzzer. We have now completed the circuit. Let's start the simulation. Glowing red LED indicates the circuit is powered, but the buzzer is not sounding as the circuit is open. When light falls on the sensor, the transistors conduct and close the circuit, and the buzzer sounds. When the light does not fall on the sensor, again, the circuit is open and the buzzer does not sound. This is how the light sensor LDR works. This circuit has many applications. A few examples could be cash box guards, security systems, and so on. You can now build your own circuit. Download the image file and submit in the assignment. Circuit explanation. In this project, the current flows in 2 paths. The path 1 is a power indicator circuit seen earlier in Project 1. When powered up, the red LED glows, indicating that the circuit is powered. In path 2, LDR, transistor and buzzer are connected in series with the USB DC power. Switch on a torch light and direct it on the LDR sensor. Since LDR sensor is a light-controlled variable resistor, when light falls on it, the resistance of the sensor decreases and the current flows from the emitter E to base B of the transistor, which in turn flows from emitter to collector, as in case of a PNP transistor, in the path 3, forming a closed circuit and activating the buzzer to emit sound. Have fun! Cheers!